Now that we've gotten that out of the way, people freak out. So I just needed to get that out of the way.
Oh my gosh.
Wait,
I don't
so
know.
does it-
I was going through the settings in Zoom and somehow I selected that and I have no idea what I did.
Why? Okay.
Anyways, do you guys just want to try just going through odd problems or every fourth problem or something like that? Would that help, or what do you guys want to do? Or do you guys have specific questions?
I told MG already that I want to go over related rates because we did that like a long time ago.
You would do that.
Else wants to do something else.
Yeah,
Fine.
that would be good.
I'll make a list of things to do. So I'll definitely make sure to try and do some related rates problems.
Yeah.
Also, someone on the RevisNow thing said curve sketching.
You're right. We will definitely work.
Oh, okay, yeah.
Yes. All right. Thank you, Roshi. You can erase that. I mean,
Oh, was that? I thought that was you, and I was like, why?
No, that's not my handwriting. Okay. So let's go ahead and do those first then. Why don't we do curve sketching first? I think curve sketching is something that a lot of people are having trouble with, and I can understand why. It's definitely something that's a little.
There's just so many like rules and like different things that you can do.
Sure.
Like,
okay.
Yeah.
What we're gonna try and do today is instead of me going through every single problem, I'm gonna try and encourage you guys to do some of them, because that way I think if you guys try and explain some of them, I think that way we can get a better understanding of it.
are you looking for the problems?
Yes, it's a very big. I think this is curve sketching right here. Interpreting function and/or derivative graphs. Well, not really. But is this curve sketching? Where is curve sketching? Derivatives and graphing? I guess that's it.
Yeah, I think so.
All right. I think that's fine. Let's go through these.
Okay.
Okay, number 5. fx. Oh, this is already a bad marker. What a nice start. Let's use a nice popping red. Oh. Also, these markers are courtesy of Maham, so thank you, Maham, for your markers. Yes, Maham bought me markers last year because I ran out of all my markers after doing the tutorials last year. Okay, fx, there we go, that's a nice popping red. We're doing number 5 on the problems, AP problems. X plus 2 to the 5th times x minus 3 to the 4th. Okay, so it's asking how many critical points does it have? What do you think is a good approach for this?
First, we have to find the derivative.
Find the derivative. Okay. That's what I did first too, and then I realized that there's an easier method. So we'll do the derivative first, and then we'll go through the easier method. That might save you some time on the AP exam if you choose to take that. So, do you want to use product rule? What's the best way to do this, or do you want to expand it out?
Oh, probably product rule.
Yes, product rule. You definitely don't want to expand this out. And if the glare is shining or something, just let me know and I can move it around, okay? All right, so f prime x, f dash x is equal to 5 times x plus 2 to the 4th. So that's the derivative of the first function times the second function plus the derivative of the second function times the first function, right?
Mm-hmm.
Okay, now what do we do?
We're looking for points where the derivative equals, values of x where the derivative equals 0.
Good. Okay, so if we set this equal to 0, okay, so if we set this equal to 0, what do you think is the next step we should take? Because solving this seems like a nightmare, but it's really not that bad. What do you think we can do?
We can one of them to the other side and then divide. I don't know.
Okay. Yes, that's what essentially. Yes, but at this level, generally what teachers like to see, and it's not a right or wrong way. It's just what teachers like to see is it's nice to be able to factor it out rather than thinking of it as moving it to the other side. You're doing the same thing essentially. At the end of the day, you're doing the same thing, but it's better to think of it as factoring it. So our common factors would be x plus 2 to the 4th times x minus 3 to the 3rd, I think. Correct me if I'm wrong. I think that's right.
No, yeah, that's
Okay. And then that's our that's our what we're factoring out. And then inside we would have 5 times what? X minus 3, right? For this one, because we would need to factor out one of the x minus 3s. We would have to still multiply that. Plus 4 times x plus 2. And that whole thing equals 0. Okay? And using the zero product property, we know that this equals 0, we know that this equals 0, and we know that this portion right here equals 0. So using this formula, we know that x equals -2. And I think, I skipped a step. I skipped that step, and you know why. X equals 3 here, right? And once again, if I'm going too fast, slow me down, interrupt me. That's completely fine. I don't take offense to that. But then finally here we have, I'm going to go ahead and expand this out. We're going to get 5x minus 15 plus 4x plus 2 equals 0. So then we're going to get 9x minus 30.
Wait, isn't it? Because it's 4 times 2.
Yes, you're right. Thank you. 9x minus 7 equals 0. That means 9x equals 7, meaning x equals 7/9, meaning we found 1, 2, 3, 3 critical points.
that is the answer. So.
That is the answer. Good. Now, I think there was a better way of doing this, and it was in the solutions that they talked about it. Do you guys know what multiplicity is? Multiplicity. I know we didn't cover a lot about it. It's generally an algebra 2 concept. But here's the thing. Okay. Think about linear functions. Linear functions, linear functions, they cross once, right? Okay. A quadratic function, if I had something like x minus 2 squared, where would that cross? The 0 would be at x minus 2, and it wouldn't cross. It touches there, and we have a horizontal tangent, but we go back up. Okay? There's a pattern I'm going to try and get you to notice. If we have x minus 2 cubed, once again, 2 is the 0, but instead of continuing down, we switch directions and we go up. We still have a horizontal tangent. What about x minus 2 to the 4th? Same thing as the parabola. It kind of looks like this, except it's like a more squished form of that. Whenever you have an even power, okay, the way to think about x minus 2 squared, that quantity squared, is that 2 is the 0, but it has a multiplicity of 2. So m equals 2. Here, m does not mean slope in this case. I just want to clarify that. Same thing here. The solution is x equals 2, but it has a multiplicity, m equals 3. Whenever you have an even multiplicity, you turn back around. Whenever you have an when you have an odd multiplicity, it actually crosses the x-axis. Okay? Now, how does that help us with this problem? All right? So keep that in mind. If we have x plus 2 to the 5th times x minus 3 to the 4th, I know that my zeros are going to be x equals -2 and x equals +3. Okay, I know that simply because I know that if I set this function equal to 0, these are going to be my whatevers I'm left with. Using the multiplicity property, the first thing we're going to do is figure out the limit as x approaches -infinity of the function. So what would be the limit as x approaches -infinity? Is it going to be positive infinity or negative infinity? Just think about the powers. The highest power is going to be x to the 5th times x to the 4th, which is x to the 9th. If I have negative infinity to the 9th power, what am I going to get? Negative infinity, right? So that means for very large negative values, I'm going to get towards negative infinity. What about very large positive values? I'm going to get towards positive infinity. Okay, so I know the end direction. Now, I know that at x equals -2, I have an odd multiplicity. Odd multiplicity, we said that it crosses. We have a horizontal tangent, but it crosses rather than coming back down. So at x equals -2, what's going to happen is I'm going to have a vertical or horizontal tangent, but I'm going to continue going. All right. Then what's going to happen? Yes. Then what's going to happen is at x equals 3. All right. 3, is another 0. So somehow the function's going to cross 0 here. Okay? But this time it's an odd multiplicity. Okay? Or sorry, even multiplicity. Even multiplicity means whatever happens from this end is going to continue. Okay? But here's the problem. Somehow this is going up, and then somehow this is also going up. That means somewhere along this line, I must also have a horizontal tangent. So I have one horizontal tangent here, one over here, and one over here. Now, I know this took a longer time to explain simply because it's something we're not as familiar with. But if you understand this concept conceptually, if you were to make a quick sketch, you would much more quickly realize that this has 3 horizontal tangents. So 3 critical points. Do you understand the premise of this? I know it's a pretty weird concept, but just remember odd multiplicity means I cross the x-axis, whereas even multiplicity means just turning point. Okay? All right.
Okay.
Sometimes calculus isn't always the answer. Okay, that's the key lesson to learn. Okay. Let's move on to maybe something like, all right. And if you guys ever have questions, like specific ones you guys want to do, just put them in the chat or say it out loud. Either way is fine. Okay. Okay. Let's think about number 14 here. If f of x equals x ln x, what is f dash x? F dash, oh, that's another, in many European countries and in European countries, they'll refer to prime as dash. Sometimes that's just a habit. I'll say both because I've heard both. But here, f prime x, f dash x, same thing. What would that be equal to? Can someone walk me through that?
It would be ln x plus 1.
Yep, 1, because it'll be 1 over x times x. Okay, good. Now, what is the minimum value of this? What is the minimum value of this function? I can set this equal to 0 to figure out critical points, right? That's not a 0, that's a 0. That means ln x equals -1. When does ln x equals -1? E to the minus 1 equals x, and you know that using your log properties. And then you know that x must equal 1 over e. But this, do not be fooled, this is not the minimum value. This is the x value at which we have a possible critical point. Now, I draw myself my little number line, and I know 1 over e is the critical point. Now, I also know, simply by the function ln x, what is the domain of this function? Can x equal 0? Can I take ln of 0? No. So that means x is always greater than 0. That means I have 0 as a critical value. I call it an endpoint. It's really an endpoint, but I pretend it's a critical. It's not a critical value. Let me get that straight. It's an endpoint, essentially, is what it is. It's an open endpoint. 0, 1 over e is my critical value, and then it goes unbounded, essentially. So let's think about the derivative. If we plug in something like, I don't know, maybe something like 1 over e squared. 1 over e squared would be in the middle here. So if I plugged in 1 over e squared, I would get ln of 1 over e squared plus 1. That would be ln of e to the -2 plus 1, which would be -2 plus 1, which would be -1. That means my derivative is negative here. So I'm going to put a little minus sign, and I'm just going to put f prime here just to remember. So f prime is negative here. And for all values greater, if I had something like positive e, ln of e here, that would be +1 plus the +1, so I get a positive slope. Do you guys know how to do this? This makes sense, right? Okay, good. So if my slope is going negative here, and then it switches to positive, that must mean that here I have a critical, it's a negative, it's a minimum value. So that means now I can just calculate f of 1 over e, and that means that is equal to 1 over e times ln of 1 over e, and we just know 1 over e is e to the -1. Since ln and e are inverse functions, I know this is just -1, so that means this is equal to -1 over e. And therefore, C should be the correct answer. Okay? All right. maybe we need to do, if we want to try curve sketching, maybe we need to do one of the free responses. Yeah, maybe that's what we need to do. Sketch. Is there a sketch here? I think there was a question that had to do with sketching. Let's see. Sketch. Yes. Okay. Good. Let us. Okay. Let's. Oh. Yes. Let's do this problem first. This is from the AB exam from 1985. Let's try this one. Number 36. Okay. So the figure above shows that the graph of f prime, this is the graph of f prime, is a derivative of f, okay? So that's important to remember. This is the derivative. This is not f, okay? The domain of the function f is the set of all x such that, okay, -3 is less than or equal to x is less than or equal to 3. Okay, that means x is an element of the closed set -3, +3. Okay, that's important. For what values of x in this interval, in this open interval, does f have a relative maximum? Okay, so for part A, relative maximum. When do we have a relative maximum? And when it asks you to justify your answer, I'm not writing it out in complete sentences, but you would write it out in complete sentences. When would you have a relative maximum? Derivative definition-wise.
When the derivative goes to from positive to negative.
Exactly. When f prime switches, or let's, instead of switches, let's say f prime changes signs from positive to negative. Okay. When f prime changes signs. Okay. Where does that happen? Where does f prime change from positive to negative? Be careful here. You're not looking for the slope of this graph. You're looking for the graph itself. Go ahead, Alina.
Well, I was just going to x equals -2.
-2, perfect. Yeah, I think that's the only value, right?
Yes.
Yes. So -2. So that means that therefore x equals -2 is there. Okay, here's what I would say. F has relative maximum at x equals 2 because f prime changes signs, blah, 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 blah. You know the rest. Okay. Similarly, the relative minimum is when f prime changes signs from negative to positive, right? Okay. And where does that happen?
X equals 0.
Exactly, at x equals 0. Good. So that happens at x equals 0, and using the same justification essentially. Now, conceptually, what happens at x equals 2? What is that? What is going on right there?
That would be essentially like a saddle point at which the slope kind of tops out and then kind of goes back up.
Yes, exactly. So the slope is positive at first, so it'll probably look something like that, right, Ashwin? Like it'll have a little saddle point right there. Yeah, okay, good. So now, for part B, what values of x is the graph of f concave up? How would we approach that? For what values of x is the graph of f concave up?
The second derivative has to be positive.
Okay, and how can we find the second derivative using this, what they've given us in the problem?
You can use like the derivative of this graph and see where the derivative is increasing, or the tangent line is increasing and where it's decreasing.
Good. So what intervals would those be?
-1. Oh, you can say.
No, it's okay. You can go.
-1, 1, and then 2 to 3.
1 union 2, 3. Okay. Now I put open brackets for these because at x equals -1, it isn't necessarily. It's an inflection point. It's not neither concave up nor concave down. Sometimes in the answer key they'll put a closed bracket. I disagree with that, but it's a matter of definition. Okay. Now how would you justify your answer? You would say that the f is concave up in these intervals because the derivative of f prime, which is the second derivative of f, has a positive, is positive. I think that's the easiest way to explain it. Okay, to justify it. Okay, so let's rewrite the information we obtained. So concave up, because it'll be helpful for our sketch. It's concave up on this interval, okay? We said that where was the maximum, the relative maximum? We said that was at x
X
equals
-2.
and relative minimum at
X equals 0.
x equals 0. Okay. And then we also said that potentially there's a saddle point at x equals 2, Ashwin said. Okay.
So do we need to know saddle points?
I mean, yeah, essentially you do, because when you're graphing it, you need to know what it'll look like. So I don't know how you would know that without graphing. So, okay. So if this is x, this is y. All right. The first thing I would try and do is plot points, which sucks because they didn't give us any points, right? They didn't give us any points of f. So if that doesn't happen, then the next thing I would try to do is figure out just to sketch the relative maximum and the relative minimums, and where anywhere where the derivative is equal to 0 or does not exist. So the relative maximum is at x equals -2. So at -2, this is going to be the highest point in the graph. So I'll just draw a pretty high point right there. My relative minimum is at x equals 0. So at x equals 0, I'm going to have a pretty low point. So let's just say it right there, okay? Saddle point at x equals +2. So that means I'm going to have something going on here, and I know it'll be positive, but then it'll do something like that. I don't know what it'll look like yet. So I'm just going to kind of, so I draw this in very lightly at first. So what I'll do is I know this is a maximum, so I'll do something like this. And I know that's a minimum. Okay, this is hard sometimes. But also, if you see, -1, x equals -1 is where the inflection point is from the graph. Why? Because the derivative of f prime changes from negative to positive. That means at x equals -1, I have an inflection point. So the way I mark inflection points is with an x. So there's going to be an x here, changing from concave down here to concave up here. Okay? So that takes care of that. And then let's see. Then there's another inflection point at x equals +1. So at x equals +1, that's my other inflection point, and that's x equals +1. And it just so happens that we drew that pretty accurately. Okay. And then that'll be concave down and then back to concave up. Okay, good. And this should be more of a horizontal. Okay. I know that seemed a little haphazard, but do you understand kind of the process that I took? The process is you figure out where your derivative is equal to 0, plot those first. Because now I know that's a maximum, I know that's a minimum, I know that's a saddle. Now I have somewhere of some sort of wiggle room. Now, then what I do is I figure out the inflection points, I mark them. Then I use the concavity to sketch it. Okay? And in intermediate steps, I try and just make loose sketches. And then over time, as I get more and more information, I'll like smoothen out those rough sketches. Okay? Does that help, Alina, with curve sketching?
Yeah.
Okay. We can do another one with curve sketching. Okay. 1988, AB, calculus AB. Okay, is this okay? Can I erase? Okay. 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 So fx is equal to 2x e to the minus x. Write an equation for the horizontal asymptote. Okay, how do we find horizontal asymptotes? Think about it. Think about it hard. How do we find the horizontal asymptote of a function?
Isn't that one? Wait. The slope is 0 or no?
So not necessarily.
It would be the limit at where the slope approaches 0. So it would be like this limit of the derivative approaching 0, right?
Not necessarily either. Yes, technically that that would be a whole lot of confusing extra math. Really, all we're doing is we're figuring out the limit as x approaches negative or positive infinity of fx, right? Because think about it, if I have an exponential function, the limit as x approaches negative infinity, if I get a certain value, then that means that there's a horizontal asymptote. Similarly, if I have something like x squared, if I take the limit as x approaches positive or negative infinity, I'm going to get positive infinity. That tells me that I don't have a horizontal asymptote. So if I take the limit as x approaches negative infinity of f of x and the limit as x approaches positive infinity, positive infinity of fx, then I can figure out if this has a horizontal asymptote. So limit as x approaches minus infinity of 2x e to the minus x. Well, this is essentially the limit. I'm not going to rewrite the word limit over and over. You need to do that, but limit, and then you'll have 2x over e to the x. Okay, now what you have to realize, there's an order in which functions grow, okay? Exponential functions always grow faster than any polynomial function. Whether you have x to the 50 billion over here, doesn't matter. E to the x in the long run is going to outpace 2x. Does that make sense? Okay. And so what you have to realize is if the denominator is outpacing the numerator, what's going to happen? What is it going to do?
Zero.
It's going to approach 0. That means this limit is equal to 0. Therefore, the horizontal asymptote is y equals 0. Okay, that's as x approaches negative infinity. What about as x approaches positive infinity? It's likely to be the same, but we don't know that. Because sometimes you might have it where you have a x approaches 0, and then it goes up, and then x approaches 2. That could be a function. We don't know. So that's why we have to take both the positive and negative infinity limits. Okay. Here, we're going to do the same thing of 2x over e to the x. But this time, 2x over e to the x. I think I did this wrong. Hold on. Let's go back to the negative infinity version. Yes, I think I did this wrong. Because what's going to happen? If I plug in negative infinity here, that's really saying 2x e to the positive infinity, right? Because then it's a negative in the denominator would push it back up to the numerator, right? All right, bye, Samantha. Thank you. Do you understand what I did there? Sorry, I didn't make myself clear the first time. I did it wrong. Because we're looking at x approaches negative infinity, essentially a negative in the denominator would push it back up to the numerator. So this is really the limit as 2x e to the positive x. This does not exist, the limit as x approaches infinity. This is unbounded. What that tells me is that as x approaches negative infinity, it's unbounded. But the limit as x approaches positive infinity of f of x would be 2x over e to the x. And then as this gets larger and larger, this will outpace this, and this will equal 0. So we still do, the horizontal asymptote is still y equals 0. But the negative infinity and positive infinity does make a difference. And the reason I did this is because I need to know this information when I do my curve sketch, okay? So someone hang on to this information for me because I'll have to erase my board. Just remember that as x approaches negative infinity, we're approaching positive infinity. And as x approaches positive infinity, we have a horizontal asymptote of 0. Okay, just remember that. Okay, so that's the answer to A, part A, y equals 0. Find the x coordinate of each critical point of f, okay? For each such x, determine whether it's a relative maximum, minimum, or neither. Okay, fx is equal to 2x e to the minus x. Okay, do you guys want to turn this into 2x over e to the x and use quotient rule or product rule? Your preference, whatever you choose.
Product rule.
Product rule? Okay. All right. So f dash x equals what? Someone walk me through that. I'm going to look at, I think it's easiest to look at that as one function and then this one as another function. So, anyone?
So you start off with, oh, sorry.
No, it's okay, you can go.
Okay, so you'd start off with 2 times e to the negative x.
Yep.
And then that plus e to the negative x again, or negative e to the x.
Good.
Because of chain
Negative
rule,
e to the negative x, yep.
times 2x.
times 2x. So I'm just going to put the 2x in the front here. 2x e to the negative x. Okay. All right. What I'm going to do to make my life a little easier is I'm going to factor out a 2 e to the minus x, and I'm going to get 1 minus, or you can divide like Alina if you really want to do that.
Yeah, no, I'm not going to
Either
do that
way is
anymore.
2 to the minus x times 1 minus x, and that equals 0. That means that this e to the minus x has to equal 0, and that means 1 minus x has to equal 0. We know that this has no solution, right?
Yeah.
Yes, this has no solution. Okay. What about this? This definitely has a solution, x equals 1. That means x equals 1 is my critical point. All right. Now, looking at this, if I have e to the minus x times 1 minus x, and I plug in something, e to the minus x, no matter what I do, is going to be positive. So I don't need to worry about the sign of that. 1 minus x is essentially determining the sign of f prime, right? So when you're calculating your intervals, if you have something that's always positive, you don't need to worry about that because you're only concerned about the sign. You're not concerned about the actual value. So you can forget about the e to the minus x because that'll always be positive. So really, if I have a negative, like something like 0 here, 1 minus 0 is 1. So this will be positive. But if I have 5 here, like something that's past x equals 1, I'm going to have a negative slope. And really, e to the minus x, why complicate my questioning when I know that this is always positive? So that's why I got rid of that, okay? And same with the 2. You could have gotten the
Wait, why is e to the minus x always positive again? Or
because
I lost you there.
Think about it, right?
It's just 1 over e to the x.
Yes, I mean,
Yeah,
it's 1 over e to the x, and an exponential function always has an asymptote of 0. Yeah, okay, good. So the only critical value that I got is x equals 1, and to me that looks like a relative maximum because I'm going plus and then minus. So relative maximum. Is that the correct answer, Alina? I just want to make sure I didn't miss anything.
Which question is this?
This is number 25.
There's no answer. Oh wait, no, there is. Is there? Yeah, there is. Okay, is this B? Yeah, it's just x.
Good. Okay. All right. So someone else remember that, because we're gonna need that again when we sketch. Okay. For what values of x is the graph of f concave down? So we would have needed to find second derivative. What did I get for f dash x again? I think it was something like 2e to the minus x times 1 minus x, right? Is that it?
Yeah.
Okay. All right. Actually, I think it's easier to look at it in its separate form when we take the second derivative. I think it was like this. This was the expanded form. I think personally, I think it's easier to take the derivative of that than to take the derivative of the other one. But if we were to take the derivative of this, f double prime x is equal to what? Well, we take the derivative of the first one, would be minus 2 e to the minus x. Then we would have to apply product rule again here. So you would have minus 2e to the minus x, e to the minus x minus, that comes down, so that'll be a plus 2x e to the x. Correct me if I'm wrong. I did that kind of quickly in my head, so just correct me if I'm wrong. Does that look right? Or did I get that wrong?
Negative x?
Huh?
Like
E to the
plus
negative
2.
Yes. Okay. Anything else? Any other mistakes?
No, that's right.
No? Okay, good. All right. So to find where it's concave down, we have to find the critical values of the first derivative. So we can set this equal to 0. But first, I'm going to factor it. I'm going to take away a 2. I'm going to actually take away a negative as well. Minus 2e to the minus x. If I factor that out, I'm going to get, oh, wait. We have a minus 2 and a minus 2. These are the same thing. So first, let me rewrite that as minus 4e to the minus x plus 2x e to the minus x. Okay? Then I'm going to factor out the 2e to the minus x, and I'll get x minus 4. Nope, x minus 2. Sorry. I think that's right. Once again, correct me if I'm wrong. I do a lot of these calculations in my head, so I mess up a lot. Does that look right?
Yeah, that looks right. That's
Okay,
right.
So once again, set that equal to 0. So our only critical value is x equals 2, because once again, e to the minus x doesn't equal 0. So x equals 2. If x equals 2 is our critical point, let's figure out what happens. So 2, and we're solving for f double prime, and we're only worried about x minus 2. If I select something like 0, 0 minus 2 is obviously going to be negative. If I select something like 5, 5 minus 2 is going to be positive. So that means concave down here and then concave up here. So it asks for concave down, so that would be x is less than 2 is where it's concave down. Is that correct, Alina?
Let me check. Yeah, that's right.
Good. Okay. All right. Now let's rewrite all this things we collected throughout these parts. We know that the limit as x approaches minus infinity of f of x is positive infinity, or it does not exist. You can do whatever you want, but in this case, we want to write positive infinity just so we know that that's what it'll look like. Limit as x approaches positive infinity of fx is equal to 0, and this is our horizontal asymptote. Okay, or asymptote. Okay. Where did we have a relative maximum? I think we said it was a relative maximum, right?
At x equals 1.
X equals 1, and then we said a concave up in, or we said concave down for x is less than 2, and then concave up for x is greater than 2, right? Okay, and that means x equals 2 must be an inflection point. We know that because that's where the concavity changes. Okay, so now is the sketching part. X, y. Okay, so the first thing I'm going to realize is that I'm going to use these end behaviors. So I'm going to just slowly, I'm just going to kind of sketch in just the end right here. I know that there's an asymptote at y equals 0, so I know that it'll kind of approach there. Okay, so and then looking here, I know that we're going to approach positive infinity. I don't know if it'll be concave up or concave. Actually, I do know if it's concave up or concave down. So at x equals 2, so our big changes are at x equals 2 and x equals 1. So I'm just going to plot those in real quick. At x equals 1, we have a relative maximum. So I'm just going to plot a little point there to remind me that. I know that it's concave down till x equals 2. Okay? So it's concave down till x equals 2. Then it'll probably look something like, this is my inflection point, so it'll probably look something like this, right? Yes, that's where my concavity changes from concave down to concave up. That would be my maximum. And we said that it's always concave down. That's a little problematic. Because how does it approach positive infinity then?
I thought you just said it doesn't exist for the limit as x approaches negative infinity.
Well, it doesn't exist. If it's infinity, we just say it doesn't exist.
Okay.
Yeah. Maybe I did that calculation wrong. I did do it wrong. I did. Sorry. That's why. Okay, let's look at it one more time. So it'll be the limit of 2x over e to the x. But what you have to remember is e to the x is a negative infinity. So it'll actually go back up to the numerator and it'll be 2x e to the x. But since this is an odd power, this will approach negative infinity. Because it's 2x and not, if it was 2x squared, then we would have approached positive infinity. But it's just 2x e to the x, and therefore it's negative infinity. Okay? That's why instead of positive infinity, it'll actually be negative infinity, which makes more sense because it's concave down. Okay, this is an accurate representation, I'd say, of the graph. Yes. And actually, we should have, and I also did this wrong, actually. If we wanted to be even more precise, we know that the graph f of x has a 0 when x equals 0. because if I plug in x equals 0, then I should get it. Yeah, so that's a point on the, so if I want to be really precise, it might look something like that.
Yeah, that's what they like.
Okay, so there you go. Do you see what we did? It's kind of a, you know this, you don't know that, let's go back and fill in this, kind of that's kind of the process we're doing. I know it's a little tricky, but hopefully that makes a little bit more sense. Do you guys want to try one more from the practice problems, or do you guys feel confident enough to try it on your own later? One more? One more, okay. We can do another one, okay.
I'll be back. I have to do something.
Sure. Okay. We are going to curve sketching problems. Are there any here that actually make you sketch it? Ah, there we go. Ah, this one was a fun one. I really enjoyed doing these problems right here. These are fun ones. Okay. Which one do you want to do? Do you want to do the easier one, A, or do you want to do the harder one, B? We can do either. We can try and do the easier one and leave you to try and do the harder one. Or we can try and get the harder one out of the way and leave you to do the easier one. Whichever you prefer.
Let's do the harder one, I think.
Harder one? Okay. All right. We'll do that. Pause. Yes. All right. What's up, Zachary?
Oh, no. I was making a joke. Never mind.
Oh,
It's all
okay.
good.
Okay. All right. I'm just going to rewrite all this for my sake because I need to kind of digest it. So f of f prime x is greater than 0 if absolute value of x is less than 2. I don't know why you, that's too much, that's too complicated for me. So I'm just going to say if -2 or on the interval on x is an element of -2 comma +2. This is saying the exact same thing, right? Because absolute value of x is greater than 2, or greater than 2, I mean. Oh, wait, never mind. You would have to use their notation. If you wanted to use interval notation, it would be x is an element of -∞, comma, -2, union -2, or +2, comma, +∞. Okay, do you see how we got that? That's what they started off by saying was absolute value of x is greater than 2, and I just said this. These are equivalent statements. Okay, so that means the slope is positive on this interval. Okay, slope is positive on this interval. The next thing they tell us is f prime x is less than 0. Sorry, I read this wrong. I did do it right the first time. F prime x is less than 0 on this interval, so it's negative here. F prime x is greater than 0 on absolute value of x is less than 2. So I was right when I said x is an element of -2, comma, +2. So the slope is positive there. The next thing they tell us is f prime of 2 is equal to 0, which likely means that it is what? What's going on at f of 2? Think about this, using the information above. At up to x equals 2 from the left-hand side, we're going up. And then
the relative maximum.
Relative maximum, good.
Yeah.
Using the information above. Okay. Limit as x approaches infinity of fx equals 1. What does that tell me? That tells me that it's a horizontal asymptote. Sorry, Alina. We're going over this problem right here, 12b. We're basically, what we said was we're kind of like just rewriting the information and trying to digest it for ourselves. So we said that if f dash x is greater than 0, that means an absolute value of x is less than 2. I just rewrote it in interval notation because that's easier to read than absolute value notation. So we know that f of x is greater than 0 for that interval. And then we use that same principle to figure out the next interval. We know that f prime of 2 equals 0, which means that it's a relative maximum because up to x equals 2, it's positive, and then from x equals 2 to infinity, it's negative. So positive, negative means it's a relative maximum because the derivative is 0. Now, limit as x approaches infinity of f of x equals 1. What does that tell me?
You've got a horizontal asymptote at x equals 1.
Or y equals 1 is a horizontal asymptote. The horizontal asymptote is y equals 1, right? And that's as x approaches positive infinity. Okay. Now, if f of minus x equals minus f of x, what is that actually telling me? Do you guys know what that is? Do you guys remember that?
It means that it's like this says it's an even or odd function, right?
Yes, it'll either be an even or odd function. So let's think about it. If something, okay, if I have x squared, that means f of negative x is equal to f of x. So this must be an odd function. So this is an odd function. Odd function. Okay, so we know that it's an odd function. We also know that f double prime of x is less than 0. So that means I'm just going to rewrite this as concave down for x is between 0 and 3, and concave up for x is an element of 3, infinity. Okay, now let's try and figure out how to graph this using all this information we just collected. Okay, first thing I know is there's a horizontal asymptote at y equals 1. So let's say this is 1, and we know our function approaches this over. Now, I don't know if it's concave up or concave down yet, so I'm not going to do that immediately. So we've used this information, so I'm just going to cross it out because this isn't going to be helpful to us anymore. Okay. Now, if this is an odd function, logically speaking, if we have positive 1 as the asymptote here, then as x approaches negative infinity, our asymptote should be what? Since it's an odd function, what should it be? Okay. We got that the asymptote was y equals 1, right? Horizontal asymptote as x equals positive infinity. Since it's an odd function, odd functions are you flip it over and then you flip them over again. So what if I flip this over here and then I flip it over again across the x-axis, where is that going to end up?
Negative 1.
Negative 1, exactly. So this is where the function ends up this way. Okay. What should I do next?
Put a point for your relative maximum at x equals 2.
At x equals 2. So let's just say this is 2, and let's just say this is a relative maximum. Okay, once again, using the odd function principle, what can we tell about a relative minimum potentially? At x equals negative 2, right? So I know that there would be some sort of a relative minimum there. Now, what should I do next? I mean, logically speaking, since this is a relative minimum, the only possible thing could be something like that. It has to be concave down, right? It has to be concave down here, and it has to be concave up here. Otherwise, we can't have a...
MG, can you move your whiteboard like up a little bit?
Yes.
Okay, thank you.
Okay. Okay, where are our inflection points? That's the next thing I would look for.
There would be one at 0 because, actually no, it's at 3. At 3 and negative.
At 3 and 0 and negative 3.
Oh, yeah.
Yes, 0,
Okay.
1 at 0 because that's where it's concave down from 0 to 3, right? So if it's concave down from 0 to 3, let's say this is where it switches, right? So this is 3. You see how it switches from concave down to concave up? 3, that means at negative 3, there must also be a switch from concave up to concave down, as you can see here, right? It's a little out of scale, but you get the point. and the -3 I got from the principle that this is an odd function. The odd function principle is proving to be very handy. Since this is concave up down here, this must be concave up here, since this is another inflection point. Okay. I think that's pretty much it. We didn't even have to use the first two principles that we discovered. Did you realize that? We didn't even need those at the end of the day, because the concavity actually tells us more. So that's another observation. When you're doing curve sketching, concavity often, not always, but often will tell you a lot more, given you have other requirements. So this is what
So
it'll
usually, never mind, actually.
Okay, that's fine. So remember, okay, there was a flow chart that I sent in the Slack. Basically, the first thing you do is plot points that you know for sure. Plot f of, if they tell you what f of 3 is, that's like a little that's a chunk of gold right there. You can immediately put that down immediately. Then what I do is I plot relative maximas and minimas. Then I figure out, okay, where is it increasing, decreasing potentially, and then I can use a concavity to smoothen that out. Okay, that's my method. It's a little bit more logical step by step. Okay, I'll leave you to try part A on your own. That way I'm not taking up every single practice problem you could be doing. Okay. Chapter 4 problems. Okay. All right. Come on. Okay, all right. What is going on the slide? Oh, okay. Yes, you cannot delete a submission from school. Anyways, okay. What do you guys? What else did we wanted to try related rates, right, Alina?
Yes, we don't have to do, I know it's already like 7:25, so we don't have to do like that many.
Sure.
Maybe 1 or 2.
Is there a particular one that you decided you wanted to do, or just I know you did the rectangle one, so there's no need to do that again. Do you want to try? I don't think 55 is one of the problems we've done. Do you want to try that one?
Yeah, sure.
Okay. Okay, if the base of a triangle is increasing at a rate of 3 inches per minute. Stop right there. What do we know about? There's a mathematical statement that we can make. What is it?
The derivative of the base is 3 inches.
Okay, here's the thing. Whenever you say derivative of something, you always have to say with respect to what,
Oh,
right? Because otherwise it doesn't mean anything.
Okay, the derivative of a b with respect to time is 3 inches per minute. Inches
per minute. Good.
And
so that's the first method,
right? Yeah, increasing.
Okay. What about dh dt? It's -3, right? Because it's decreasing. Okay. They're asking me what happens to the area. So if I wanted to figure out dA dt, somehow I need to use this information and convert it to area terms. So what is area, equation-wise, in terms of a triangle?
1/2 BH.
1/2 BH, good. If I take d dt of both sides, I'm going to get dA dt equals, well, I'll have to, how do I figure out d dt of this side? What rule do I use?
Product rule.
Product rule.
So I'm going to take half b to be one function. I'll take h to be the other function. Okay, so derivative of the first function is 1/2 dB dt times h plus dh dt, right, times 1/2 b. So I'll just write that again. 1/2 dh dt, but then this time a b over here. Right? Now, we can plug in dB dt and dh dt because they gave that in the problem. So, dA dt equals, well, dB dt was 3, and dH dt was -3. So I know that this is 3/2h minus 3/2b. So what this question asks is, which of the following must be true about the area? So when, okay, so looking at the answer choices, I see words like increasing and decreasing. Okay. Area will be increasing when dA dt is positive, and it'll be decreasing when dA dt is negative, right? Does that make sense? So let's think about this. If I have 3 over 2h minus 3 over 2b, when will that be positive? When will this be positive?
Whenever b is less than h, right?
Yes, sorry, I mean, I was just thinking, I wasn't doubting anything. I just needed to think for a second. Yes, when b is less than h, area will be increasing because dA dt will be positive. Because think about it, just look at this. You don't need a calculator. I know it says it's a calculator question, but you don't need a calculator for this. You'll be wasting time if you put this in a calculator. You can clearly see that this is the minus term. So whenever the minus term exceeds or is less than the positive term, we'll have an overall positive number. So that means if b is, and because essentially, do you see how it's 3 over 2? If I wanted to even be more precise, I could actually factor out the 3 over 2. I could say this is 3 over 2 times h minus b. Since this is a positive number, it really doesn't matter. I'm really looking at h minus b. If h minus b is positive, then dA dt is positive, and therefore a is increasing. So h minus b, it will be positive if b is less than h, and it'll be negative if h is less than b. Which of my answer choices matches what we just discussed? It's not always increasing. It can't always be increasing. Can't always be decreasing. Can be constant, obviously, because since we found a function to relate it. So it's between D and C. Alina?
D.
D. Good. Do you see what we're doing? You're always in related rates problems and optimization problems when we learn about them in the future. You're going to have to rely on some formula, whether it's area equals 1/2 base height, volume equals this. You might have to use similar triangles if you're dealing with shadows. You're going to have to use some sort of formula, differentiate it with respect to some common variable, and then use what they give you in the problem and substitute that in. That's the common, I guess, the common formula to solve these types of problems. Does that help?
Yeah, I think that helps.
Okay. All right, so it's 7:30. I mean, as always, you can leave whenever you want. If you have more questions or you'd like to do more, I can stay, whatever you prefer. Would you like to do more, or would you like to end it? Whatever you prefer.
I don't have anything in particular, but I can stay.
Okay.
Yeah, I don't have any particular questions.
Okay. I think this is related rates too, and it's an FRQ. So do you want to try this one real quick?
Yeah, sure.
Okay. Oh, okay.
Wait, people left. I didn't even see that.
Few people left. That's fine.
Yeah.
And we're recording this, so if you really need to go, that's fine too. You can always go back and see later. Okay. The balloon shown above is in the shape of a cylinder with I don't know how to pronounce that, hemisphere ends of the same radius as that of the cylinder. Okay, makes sense. The balloon is inflated at the rate of 261 pi cubic centimeters per minute. I'm going to stop immediately there and write that mathematically. What do I know? What is that? How do I write that mathematically? Alina.
I guess dB over dt.
Well, what would B be? It's okay. I mean,
I don't know.
Look at if you don't know, look at the. I almost gave you the answer. Look at the unit. What is this unit?
Oh, the volume.
Yeah, the volume. The units will almost always tell you because that's what the rate of change is. So, well, I would say dV dt, right?
Okay, that makes a lot more sense.
dV dt equals what? 261 pi, right? And it's increasing, so it's positive. I'll just write centimeters per minute, but usually when you're doing problems quickly, unless they change the units midway, you don't need to do that. Okay. At the instant the radius of the cylinder is 3, so that means when r equals 3, the volume of the balloon is 144 pi. So V equals 144 pi. And the radius of the cylinder is increasing at the rate of 2 centimeters per minute. What does that mean?
dr over dt equals
2, right?
yeah.
But the important thing to remember here is that's only when r equals 3. Okay, so this is how I'm going to write it. When r equals 3, dr dt equals 2. I can leave a little bit more space. Equals 2. Okay. Now, of course, we know that the volume of a cylinder is pi r squared h, and the volume of a sphere is 4/3 pi r cubed. So what is the overall, okay, I'm not even worried about the questions first. First thing I'm going to do is figure out a formula. What is the formula I'm going to use? What is the total volume of this figure?
The volume of the cylinder
That'll be pi r squared h plus,
plus the volume of the sphere.
yeah, and instead of,
It doesn't.
like, yeah, it
It
doesn't
doesn't
matter,
really
right?
matter.
'Cause it's-
Yeah.
you understand.
Okay.
Okay, so 4/3 pi r cubed. Okay. Okay. All right. What do we suggest we do next? What would be a reasonable thing to do next?
Find dA dt, so the rate of the change of the total volume of
dV
the
dt.
entire figure.
Now, why? Okay, Alina, the question is asking for height, right? The first thing I'm going to realize is that right off the bat, there's no way I'm going to figure out what height is unless I know the radius for sure, right?
Mm-hmm.
Actually, I think we can, because they tell you at this instant, right?
Yeah.
At this instant means r equals 3. So let's try and see if we can. I think actually we can. We don't need to do calculus for the part A. For part A, we know volume. They tell us when r equals 3, volume is 144 pi. And we know that r is equal to 3. So this is 3 squared h plus 4/3 pi times 3 cubed, right?
Yeah.
And now you just solve for this. So this will be 144 pi equals 9 pi h.
Oh, so we're solving. Oh, okay.
Yes, for the first one.
Okay. Yeah,
So
makes
we didn't
sense.
need to do calculus for that because they already gave us all the variables we needed. So
Okay.
usually, and here's another general tip. If you solve the problems in order on the calculus exam, like you can't solve them out of order is what I'm saying. Like you can't solve them out of order, usually. Like each question builds on the next. So whatever answer we get here is going to help us answer the next question. Okay, that's
Okay.
important.
You mean like
okay?
in part if it has like parts?
Yes, it has parts.
Yeah. Okay.
Not the multiple choice. Yeah. Okay. And then this would be 27, but then 27 over 3 is 9. Yes, 9. 9 times 4 is 36, so this will be just 36 pi. I can subtract 36 pi from both sides, and I would get 14 minus 6 is 8. 4, 3. 3 minus 3 is 0. 108 pi, I believe. Yes, I think that's right. And then 9 pi h. That means h is equal to 12. Okay? So h is equal to 12 centimeters. Make sure you put your unit on the final answer, and you're good for. Oh, this is something Mr. Clarity taught me. Do not
Which
box.
question is this?
This is 60 part A.
Okay. Sir, just to make sure.
Yes, please check. That would be good. Okay. We don't want to make
60 part A.
Yes. 12 centimeters.
Yeah, it's 12.
This is something Mr. Clarity taught me. Do not box your answer. Okay?
Why not?
Why not? Because, well, for class test, you should, but on the AP exam, boxing it doesn't get you any credit. The reason why boxing might actually hurt you is, say for example, you had the correct answer h equals, like say the correct answer was h equals 15 centimeters, and you had shown all the proper work and everything, and for whatever reason, you accidentally rewrote it as h equals 12 and you boxed that. Guess what? Now all the reader is going to look for is this box. And even if, like, here's the thing, the box draws attention. So for whatever reason, if you have the correct answer somewhere else, or you did partial credit properly, all they can see is the box. So it's a psychological thing, but also there's just a higher probability of you getting it wrong if you box it. And this is just on the actual calculus exam, the AP exam.
So if you put like 5 answers and one of them is right, it'll be like correct?
Not necessarily. It gets tricky at that point.
What? That's so much.
It gets tricky. It gets very tricky. What they want is an answer consistent with your work. That's what they want. So, and here's another good part though. Say you had gotten h equals 13 here, and then you started using h equals 13 on the next problem, but you set your work up properly for the next problem and you got an answer consistent with the work. They wouldn't mark that wrong. That's the nice thing about AP. So they've changed their rules. Yeah. So if, say for example, you got h equals 13, and remember how I said each problem, each answer is, if you use h equals 13 in the next part of the problem, and you still set your work up properly, your answer is going to be wrong because h equals 13 is wrong. But since you set your work up properly, and had you chosen the correct, they'll give you credit for that answer.
Like,
Basically, because you were following the process for the second one correctly, but
Yes.
it's just you
They'll
had
give
the wrong information from
will
the
they
start.
give you like full credit, or is it like
No.
partial credit?
You'll get points for the work. Like on the rubric, I remember on the
Interesting.
chemistry exam too, on the rubrics, what they say is plus 1 point for calculation that shows moles per grams or something consistent with their answer, consistent with the student's answer to part 2A. And then for part 2C, they'll say plus 2 points for calculations from moles to Kelvin. I don't know, I'm just making something up. Moles to Kelvin that are consistent with the student's results from part 2B or something like that. They'll say, that's what they'll say.
Okay.
Now, it's not always like that, but like what I'm saying is don't worry about that. Just do your best to solve the problem and don't worry like, oh no, this one problem is gonna mess up my entire score. Don't worry about that. That's usually not a problem. Okay, h equals 12, good. So part B, how fast is the height of the cylinder increasing? What we're essentially trying to find is dh dt, right? So now, in order to find dh dt, the only plausible way I can think of doing that is by finding dv dt from this formula. That's the only plausible way I can think of doing this. So dv dt. dv dt is going to equal, I'm going to need more space for this. dv dt is going to equal.
Didn't they give it to us?
Huh?
Right?
Yes, but I need a formula in terms of something. I need dv dt in its like algebraic form, because that'll allow me to get to a dh dt somewhere along the line, and then I can isolate for dh dt by substituting that dv dt that they gave us here.
Okay.
Otherwise, there's no way I can get dh dt, right?
Yeah.
We're not solving dv dt because we want to know what dv dt is. We know what that is. We're solving dv dt so we can find dh dt.
Oh, okay.
Yes. So this will be 2 pi r h dr dt plus,
Wait, what?
I'm taking the derivative of this, 2 pi r dr dt h plus, it's product rule, plus
Oh, okay.
pi r squared dh dt plus 4 pi r squared. There you go. That's your derivative. Now we can actually just plug in everything we have and just solve for dh dt. We know dv dt is equal to 261 pi. 2 pi r is just 3. H, we found in the last problem, h was what, 12, I think?
Yes.
Okay, 12. Dr dt is 2 plus pi times r squared. R is 3 squared. Dh dt, and this is what we're going to eventually solve for, plus 4 pi r squared. So r is 3 squared. Okay, now we just have to solve for this. So I'm going to erase from the top and I'm going to keep solving. Okay, so we got 261 pi is equal to, 3 times 12 is 36, times 2 is 72, times 2 is 144 pi. Okay, 9 pi plus 9 pi dh dt. 9 times 4 is 36 pi plus 36 pi. Well, okay, so this is what I got up to. Okay, so now 4 plus 6 is 10, 4 plus 3 is 7 plus 1 is 8, 180 pi, 261 pi is equal to 180 pi plus 9 pi dh dt. Now subtract both sides, subtract 180 pi from both sides, and you'll get 160 minus 8 is 821. So 81 pi is equal to 9 pi dh dt. Cancel pi's.
Just equal to
That means dh dt. And what's the unit?
equals 9 centimeters per minute.
Minute, I think? Yeah, minute.
Yeah, minute.
There you go.
We're supposed to box art.
Oh,
I'm just
No,
kidding.
you're-
I'm just kidding.
Wait,
Keep
can you go
making-
back to the bottom where you had like everything, all the stuff plugged in? Where did you get that 12 from?
12 is the height. Remember, we solved that in part 8. Remember, that's why I was saying everything you solve for.
Oh, yeah. Okay.
Okay.
Got it.
Wow, this is kind of lengthy.
It is lengthy. But yeah, there's a lot
I
of
think,
room for error, which is kind of
yeah, I think like once you got it to like where it's like dv over dt equals like once we got there, I like got how to do it.
it's just setting up the formula that's it. So yeah,
Yeah,
sometimes it's
setting up
unintuitive because it's like, why am I finding dv dt when I know what dv dt is, right?
Yes, that's what
Yeah,
confuses
I get
me.
that, I
That's
get
what
that.
confuses me. Yeah. Okay, but I think that makes a lot of sense now. Okay, let me take a picture of this so I remember. Literally, my entire camera roll now is just pictures of my whiteboard of math, and I don't really like that. But you know what? I guess it's just the way things are.
Status quo, the way things are. Important. What happened in important?
Oh, I think Samantha announced the team leads.
Oh, cool. Congratulations, Alina.
Is it there? Okay, I don't know. I didn't know. I was not aware. Oh, that's fun.
Nice.
We know that you were all excited about voting. We had to make an executive decision.
Okay. All right. Do you still want to go? I mean, I'm available. If you need me to do more, I'm more than happy to do more. Whatever you guys want. We can. Do you guys want to do more from this packet, or do you guys want to go back to homework or PowerPoints, whatever you want to do?
Did
I
both
think it's-
classes have the same quiz?
Which was? Oh wait, there was one. I don't know if you
Yeah, I
do.
wanted to go over a question from a quiz.
Yeah, me
Yes.
as well.
Which
I
one?
wanted to go over. I think I made a dumb mistake on this one.
Is it the graphs and linearization one?
Yeah.
Yes. My question was about the one that was like, if the radius goes from 10.1, like 10, something like that. This one.
Wait, which one?
Question 3, I think.
Ah, okay.
I think I made a dumb mistake on this one, which is why I was.
I think you must have taken 10.02 and you probably got this answer instead. If you got 10.02 instead, if you took 10.02 as the radius, and here, I'll show you.
Yeah, I'm not even sure what I did for this one. I think doing questions from this packet is really helpful.
Yes, I'm sure questions from that packet are going to show up on the test. I'm like
I know.
90% sure. Okay.
I wouldn't
Use
be surprised if it
differentials.
was, like, all of it.
Okay,
Never mind.
So the radius is increased from 10 to 10.02. Okay, what's on the chat?
Bye, Ashwin.
All right, bye, Ashwin. Yeah, no problem. Glad you were able to make it. Okay. Radius is increased from 10. That means initial radius is 10. And that means final radius, I'll say, but here's the important part. The important part is that the radius is 10. What's my change in the radius? I know I'm writing dr. It's really a delta r, but I'm going to treat it as, here, let's do this. Delta r equals what? If my final radius is 10.02, what's my delta r?
0.02.
0.02.
0.02, and I'm going to treat that as my dr because Same idea, change in R. Okay. Now we're using volume of a sphere. So if I have volume of a sphere, what's the formula?
4/3 pi r cubed.
Yes, 4/3 pi r cubed. Okay. Now we need to use differential.
Change in the volume.
So here's the question. What are we finding? Are we finding
dv dt or no?
That's what I wanted to ask. In a related rates problem, you would probably do dv dt with respect to time. But is time even a factor here?
No.
No. Here's the thing. They want us to find the change in volume. Change in volume is dv. We know what dr is. Logically speaking, the only thing that could make sense is dv dr. So I'm going to take the derivative with respect to r of both sides, and I'm going to get dv dr equals.
Oh my gosh, I literally remember. Oh my god.
4 pi r squared, right? And I don't need to write dr because technically that is what it is. It's dr with respect to r, but obviously we know that that's 1 because it cancels, which is kind of cool.
One second, I just realized something. Samantha just asked something.
Sorry, what? Okay.
I was just responding to something.
No, you're right. Yeah, that's kind of a frustrating thing. Okay, anyways. dv dr equals 4 pi r squared. And now we use what's called separation of variables to say dv equals 4 pi r squared dr.
So in this case, we're trying to find dv, right? That's
dv.
Okay. Yeah. That's sorry.
Yeah.
That's
and then r squared, we just plug in 10. We get 400 pi times 0.02. I know I was a little confused at first whether to use 10 or 10.02 as my R here, because you're going to get different answers if you do it differently. You would have gotten D instead. But the important thing here is to see that it's increasing from an initial state. Whatever your initial state is, that's the radius, right? This is after the change, okay?
So if it gives you something like this, then you use the initial radius?
Yes, you use the initial. Because think about it,
when would you ever use like the
I can't think of a context like that, because think about it. When we're taking derivatives, we define it as the limit as, okay, if I have an x here and then I have an x plus h here, we're concerned about it as it approaches x, not the x plus h, right?
Yeah.
We're concerned about this is the h is just the differential. It's what's changing this way and what's changing. We're concerned about just that x value. Okay.
This was pretty simple. I don't know why I didn't get this.
Also, this question was on the AP practice, the AP problems. This question.
Oh,
Can you do that one?
Yeah. Sorry, Zachary, did you say something?
Could you go over that one?
Oh yeah, for sure. Okay.
This one I just sat and thought about for like 2 minutes, and I was like, okay, I think I know which one it is. And then,
You have to use process of elimination here. So
yeah.
it has to be continuous. So if it's continuous, that breaks that choice D is gone. Okay. So let me just write out A, B, C, D, E and cross them out. A, B, C, D, E. Okay. D, we said we're going to cross out because it's not continuous. Okay. Let f be the function that's continuous on this closed interval. F prime of 0 does not exist. So if f prime of 0 does exist, we can remove it. F prime of 0 exists in C, so we can get rid of that. Okay. So C and D are out of the game. Okay. F prime of 2 has to equal 0. So A works, B works, and E works. So that didn't eliminate anything. F double prime of x is less than 0 for all x except x equals 0. Okay. So F double, essentially it's always concave down except for at x equals 0. A is off the because it's concave up. F double prime is greater than 0 in that interval. I don't need to write that, but you get the point. B is also wrong for that same reason. There's a concavity. It's concave up for certain values of x, and thus E is the only answer that matches. It works.
All right, that makes sense. That makes sense.
Wait, can I see what the last one was again? I kind of forgot what it was.
Oh, the last question, this one?
Yeah. Actually, no, not this one. I think it was the first one for you then. Yeah.
Oh, this is it's the problem that this is the other problem that she gives like 5 times.
This one?
Yeah, it's on the AP practice problems. It was on the homework she went over in class, and it was on here. So it's like I was like, why should I even work out this problem? Because I had like seen
Oh yeah,
this
this
so
is
many
the one I
times.
did in class. I
Yeah.
forgot. Yeah, I remember now. Okay.
Okay.
Okay, I think I am going to go.
Okay. Zachary, do you have any more questions?
No, I don't have anything.
All right. Thank you guys.
Thank you for doing this. I know
Yeah,
it's,
no problem. No
Oh,
problem.
yeah, thank
it's
you.
been a
Thank you.
long time.
No problem. All right.
All
And
right,
I
thank
will make
you.
sure to upload this to the YouTube channel. If you guys are not already following the social media for RevisNow, please do that. That way we can expand.
Yeah, look at
Right.
MG plugging his social media.
I'm not even managing that. Rhea is our social media manager. She's really good at that, actually. She's really, really doing a good job of that, I think. Okay. All right.
All right, okay.
Bye, guys.
Bye.
All right, bye.